these are kind of some 4 things that we picked out as common calls that we're getting tech support. Guys at the top are getting tech support calls about. And I don't have time for all of these on here, but you could at some point today snap a picture and then spend some time with podcast and YouTube on any of these, and you're going to grow as a technician. So who in here feels like they could use a little more training on ductless systems? Great. One of the best things you could do is have that YouTube playing in your pocket and in your ear, and search something like failed board on a ductless system. And you got it playing in your ear, you know when to stop and zoom in. If someone's talking and working through the problem, you pick it up basically like a podcast. Stop, what are they talking about here? Take a look at it, put it back in your pocket. Like, you can actually learn quite a bit on it's like running on those calls yourself. There's a lot of technicians out there that are crappy. They have sucky videos. They maybe are doing the process a little wrong, but that's how we all usually show up and try to walk through diagnosing a ductless or something weird we haven't done before, right? So you can still get those reps on things by just listening, reading, watching a little bit more. So it's not always just what content does HVAC school have on this. I would encourage you also to check out just the random tech that likes to record as he goes out there, and you will pick up a lot. I'm going to focus this morning on ductless, and then we'll hit some of these other topics in the weeks coming up. And on ductless specific, before the year is over, I'm going to have a full service. We've done maintenance videos and processes on ductless. If you haven't seen that, go look up the Sam and Bert maintenance ductless video that we did in here. It was fantastic. But as far as service goes, we don't have a lot of videos and stuff. So I'm going to put together a presentation that may take us a few weeks to get through, 15 minutes at a time, and trying to go dive into a little more detail on ductless stuff. All right, with our ductless, what are our general brands that we are spending most of our time working on? Mitsubishi, Carrier.
Mitsubishi.
Yeah.
Daikin.
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 I love Daikin.
And then a bunch of random off brands out in
Fujitsu.
Greer.
Which is mostly Fujitsu.
Yeah.
Fujitsu.
Yeah. Okay. If you get stuck on a ductless system, you're not really sure what's going on and how to figure it out, what's the best next move?
RTFM.
Okay, manual. Elliot says manual.
Go to the board and leave.
Go to the board and leave. Austin is fired again.
Oh,
Please have senior tech returns real quick.
I called tech support a couple weeks ago, and the guy's like, oh, it's going to be, oh, no, wait, you're a triple star diamond platinum dealer. We'll get you in. You'll jump the line. So.
I got a phone call from Luis yesterday on the ductless system, and halfway through the conversation, he let me know that he had called tech support before bothering me, which is fantastic.
Bonus points for Luis.
Yeah, I didn't have anything other than what tech support had given him to offer. And I would say that you may be waiting in line. If you get hung up on a ductless system and it's not your typical, I'm low in refrigerant, I'm looking for a leak, please don't call tech support for that one. But if you get hung up, you're not sure what's going on, get in line with tech support. Then look up your manual while you're waiting for tech support. And you guys can tag team it, manual tech support together. So yes, tech support is a great resource on this. One of the best things about it is that you end up learning more than you learn from me. They're getting paid to support you. I am too, but I'm also getting paid to support a lot of other people at the same time usually. And I will often just try this, and then if that doesn't work, quote this, instead of walk you through the manual or process, right? So I think you've all known tech support teaches you pretty well. It's great until it's not. All right, great. Got that out of the way. The next thing is, oh, I didn't put it up there. What are our great resources, technicians, for manuals on mini splits?
MyLink Drive.
MyLink Drive. Everything Mitsubishi, MyLink Drive is pretty good. So, huh? Blue On,
You
also.
can get a whole 3 manuals a month for free now.
Blue On is also a good resource. They have all that stuff. If you go to MyLink Drive for Mitsubishi and you search your model number, or you can just keep following the prompts, pushing buttons as they lead you through it, you'll get to your unit. They have installation manual, they have a diagnostic, they have a maintenance, like breaking stuff, taking things apart. So look at your different labels. You're typically going to be going to the service manual for troubleshooting and walking through like different sheets. You're not always going to find your exact problem, but often you'll find the answer to your problem through one of those flow sheets by walking through it. Does that make sense? So MyLink Drive for Mitsubishi Carrier, you want to use the service support app they have, which is called
Service Tech. Carrier
Service Tech. Yeah. Service Tech. Yeah. Carrier Service Tech. And that one usually has a little bit more than like the CE app as far as documents go. You can just sign in as a guest and put your model in there, and they will have a service manual on their ductless stuff, which talks about how to take it apart, and some flow diagnostic, not nearly as good as the Mitsubishi manuals, but they have some support there. All right, moving on for manuals. Now this is going to be a lot about general rule of thumb and just stuff to help you be a little bit more confident on ductless systems. So we're going to start out with charging an EEV system. Can we charge our ductless units when they're low?
Yeah.
Yes, we can. We are told that we can't, and it is common practice in ductless units not to charge them. And why is that?
It's easy to overcharge.
Very easy to overcharge. Yeah, what'd you say?
He said critical charge.
Critical charge, which is the same thing. They need to be pretty exact. If you go over the amount of refrigerant that it should have, it causes a lot of problems with compressor trying to run full speed, going out on high head. So if you're slightly under, the system will usually run decently well, slightly low on charge. So if you're gonna mess this up, I'd rather you be under rather than over. Another issue is that technicians are used to charging normal split systems, but the refrigerant and split look a little bit different on your ductless systems. The refrigerant levels are lower. So you'll have a system running full stage, and it might be 119 PSI, and you're like 35, 34 saturation. You could be as low as 32 saturation, where that coil's right on the edge of freezing and everything's running perfect. 109 PSI on your suction and everything is perfect. They try to rev up the compressor fast enough to lower the pressure on that coil as close to freezing as possible without freezing. They have a temperature sensor in the air, a temperature sensor on the coil. If it starts to freeze, they'll just slow down the compressor a little bit, and that brings the pressure up and the coil gets warm. And so their constant monitoring is how they run so efficiently and allows them to run on the edge of freezing without freezing. And so that's why you should expect lower pressures on a ductless system. yesterday, let me finish charging. When you are charging, you go to add refrigerant to a system. The thing that makes it tricky is that it's an electronic TXV. The electronic TXV measures the line temperature electronically on the suction and then electronically adjusts based on what it's measuring. If you add refrigerant, you change the temperature of the line. As the refrigerant rushes in, it creates a really cold line, which means your electronic TXV starts to adjust as soon as you start adding. Then you have to stop, let it circulate through the whole system, let that line come back to a normal pressure, normal temperature, run for a few minutes, let that thing settle somewhere to know if you need to keep adding or not. When you're adding to a ductless system, you're charging based on superheat. You're not trying to get it up to 40 saturation, you're trying to get your superheat down below 9 degrees typically. And so it can be as low as 2 degrees superheat, and that's totally normal for a ductless. Typically, you almost never run into it above 9 degrees if everything's perfect on the charge. So when you're adding, you add a little bit, TXV starts adjusting, you have to stop and let that settle, everything go back to normal before you add a little bit more. So the process is much longer than you think it is. If you try to speed that up, it's very easy to overcharge this thing because the TXV is adjusting as you add. So there's your advice on that. The other thing is that you have a variable compressor, and this is what I was going to talk about. Luis called me and he had a 165 PSI, and let's just say that is 54 saturation. How do you do that?
Ref tools.
58 saturation, and then he had a 1.5 superheat. So this is PSI. He calls me on the ductless. It's not keeping up. Any ideas what to do next? Add in refrigerant, says Eli, okay. There's no reason to think this is low on refrigerant. Thanks, Eli. The temp split was 20 degrees currently.
What brand?
Mitsubishi.
Head or four-way?
Okay, it could be, it was a side wall mount.
Is it running in full stage? Or is it running
It's not running in full stage.
It's a TXV.
Turn it down as far as it will.
It's not running in full stage.
Yep.
You have a variable speed compressor, and that affects refrigerant and charging. Your compressor adjusts based on load or based on demand. So in this situation, he had the temperature down, but the customer had set their fan speed to super quiet. So the inside fan is running really low, and that locks the compressor from going into full speed, otherwise it could freeze. So they have this little backward safety where if the fan's in low speed inside, the compressor can't run full speed. So if your compressor is running in a lower stage, suction pressure is higher, coil temperature is higher. He bumped the fan speed up, dropped the temperature down, and immediately we got to our nice 28-degree split, everything running great in the system. So that lesson is all about the fact that we have a variable speed compressor that will adjust based on demand. You need to be running in full speed stage when you're testing this and when you're diagnosing it. And then there's little things that can affect that. You could always drop the temperature down, but it's not running at full speed. Fan speed could be an effect on it. Coil starting to freeze inside. We had one recently where me and Justin were on it. The blower was really nasty. So when it came on full speed, the coil would start to get cold enough to go into the freezing stage, and it would bring the compressor down to a lower speed. The suction pressure would come up, that way it doesn't freeze, and then the system would just shut off and wait for a little while and come back on. So it was really hard to figure out what was going on. It turns out it just needed more airflow inside to keep the coil above freezing. So if you're low on refrigerant, they will also bring the compressor down. It'll come on, it'll kick on really hard, it'll come down really low. As soon as it gets to a very low point, it slows the compressor down and lets the refrigerant levels come back up. If you don't see that happen, you won't know that you're low on refrigerant, watching it all the way from the starting point through. So just remember, with a variable speed compressor, you want to turn everything off, turn it back on, listen, you hear your compressor come on, you'll hear it rev up all the way, and then sometimes you'll catch it slowing back down because it's got a problem. Maybe it goes out on high head and it revs down just to try to keep it from high pressure on the other side. So, variable speed compressors. I am excited to outline a lot of these things for you and put together an actual detailed presentation on all of these things. In the meantime, if you're not confident on ductless, take a picture of this and then try specific searches related to these topics. These are your common points on ductless. So, operation and remote. Understand the remote, become an expert on that, read some manuals, talk to some installers. Setting expectations. The biggest callback prevention is just letting the people in the villages know to set it and leave it. Drop it a little lower than you think, don't touch it. These things are amazing at maintaining temperature. You don't have to turn this thing off to save energy. You leave it on to save energy.
It also, the fan will run.
It runs non-stop. It doesn't shut off. That's how it's designed.
There's an option to turn that off.
Let's not tell anyone that ever.
No, at the training, the guy, he was telling
Let's
us.
never tell anyone that. It runs non-stop and we like that. All right. And drains and pumps. That only problem. You guys have been on a ton of those. So understanding how different drains can be maintenance. We do have videos on the cleaning side of it, like I said. Cleaning, taking pumps apart. Let's watch that. Refrigerant and split. It's lower than you think, but if it doesn't have a low superheat, then it's probably low on refrigerant. You could be 109 psi, 32 saturation, and 2 degrees of superheat. Great. It's gorgeous. This thing is running perfect. It's not low. High superheat? Yeah, we are low on refrigerant. Error codes, manuals, tech support. Wiring. Before calling tech support, it's always a good idea to check all your wire connections. High voltage, communication, plugs, things like that.
Is there a pro tips, because they always tell us to replace the entire line. And
The
that's
wire?
usually never the fix.
The wiring?
Yeah.
Yeah. The pro tip there is that if you're in a situation where you think, or tech support thinks it's the communication wire between inside and outside, is you can usually take a wire from your truck and connect communication and see if it happens, or you can take your meter out and ohm the connections, making sure with power off that we don't have bleed between one wire and the other. And then comparing voltage inside and outside. What voltage do I have outside, come inside, do I have the same inside? Okay, then it's probably not my wires.
And that's gonna be the S1, S2, S3 wires, right?
Yeah, exactly. And then understanding if there's anything else that could be breaking those wire connections, like a safety tied into the pump or a humidistat relay that we put on to pass inspection. So there's a lot of other things that could be there. You have to slow down and just trace that wire and follow all of its connection points. Cleaning, check out the videos and get some reps. Don't be afraid of that. Leak search and flares. It is the most common place to be on the flares. Don't be just quoting an inside coil if you haven't checked also that inside flare joint. Let's make sure we catch all the leaks. Bib kit for situations when you can't pull the blower off, but it's really dirty, or the evaporator coil has a nasty smell or clogging on there. That would be bib kit application. And so we have videos on cleaning, bib kit, we have drains and pumps, and videos, and the rest of this, you guys spend some time looking around. I'll put together more PowerPoints. And in the upcoming weeks, the next 2 weeks, we'll be going over communication issues on Infinity and Elite systems. Airflow, still really common. Callback and diagnostic help needed, and TXVs. You could pretty much talk to TXVs every week, and it'd be helpful. So that's what you have coming ahead.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community, for techs, by techs.